So let's use the endo rule to draw the correct structure of the cycloaddition reaction. Once again, there's no difference here, is we have to realize that there's a connection between forming between the diene and the dienophile. So again, you're forming bonds. I know it looks like a weird structure, but it's really follows the same method that we used before. Okay, so we have a bicyclic ring structure, as you recall. So the flap now is going to be, and let me highlight this in yellow so you can see it. That is not going to be, and I'll use a different color for this here so you can see it, this right here. That is no longer going to be sort of like a triangle or like a house. It's going to be flat. So take a look at this. And like I said, I will highlight it in a second. So I'll highlight it so you can see it. You have 6 carbons in there. Okay, so how do we draw the endo of this? So you would like to now add this whole group right there downward. So it would look like this. I'll draw it in a different color so you can see it. Like that. So it's pointing down. It's not the best picture. Again, do your best on it. Just make sure it's not going up, but actually going down. So maybe you should pause and draw again the endo of this. The endo is only going to apply to this one right there. Uh, this one is going to be pointing up. So maybe pause the recording and the video and then work on this one. Okay, so you just pause now. So again, here's the okay, so we have a flap now, not like that flat as we had in the cyclohexane ring. Let me redraw this. Here we go. So we need it to be endo. So this is pointing down. And the methyl group actually would be pointing up because it's on opposites. They're on opposite sides. So this is trans. You can think of it that way. So you can't have them both pointing down because they are on opposite sides, which actually brings us to acyclic die-ins, you can also draw them like what you might ask, okay, well, how do I know uh, where those groups on the outside, where do they go in the final structure? And that's a fair question. What you would do is you would really follow the same idea. You would just need to mark some things here so we could remember them. So these are outside groups. And of course, this is our EWG. Okay. And these H's are actually on the inside. So just keep that in mind, is if you have, and this is basically the easy way, so I'm just doing it here, is whatever is on the outside will remain in the final structure on the outside or on the same side, and along with the EWG. But notice how the EWG, or the electron withdrawing group, is pointing away from the diene. So let's take a look at this. So the product would be, again, here's our OCH3, OCH3. Notice how they are on the same side. Along with the electron withdrawing group. There's no ring, by the way, ring structure here. Plus enantiomer. Well, let me draw the enantiomer. So the enantiomer would be the wedges, exchanging them to wedges, if you hashed wedges, if you recall that from organic one. So that's the enantiomer. And exactly, that's the general rule that I wanted to mention here, is that if the outside substituents on the diene and the electron withdrawing groups on the dinucleol are on the same side of the ring in the product, so again, the outside and the EWG are on the same side of the ring. So you will not go wrong in drawing them all pointing out or pointing in. But do not draw one of them pointing in and the other ones are drawing pointing out. So for example, this is incorrect. So this is incorrect. They have to be all on the same side. So that's an easy rule for you to remember. What you should be doing is you should be doing the last two parts, and then we'll check these when we come on Thursday, when we meet on Thursday. Synthesis using the Diels-Alder reaction. Try them. Make sure you watch any parts you need, complete the notes, submit them before we meet. Again, I understand it could be a lot, but this is just the start. So we need to, in a good way, we need to maintain a good, a disciplined approach and an approach that that is proactive. So we'll see you Thursday.